Welcome. We're working with synthetic division, and we're also going to be working with synthetic substitution today. Now, synthetic division is a method of dividing two polynomials, but it has to be in a very specific form for this to work. First of all, you have to have a 1 coefficient for the x term, or the x to the first term, and it has to be plus or minus some constant. Now, the a value goes down here, and you'll see that in a few minutes, but the trick to this is because it's minus a, it's opposite what it looks like. This looks like negative a, but it's actually a we're going to be using. So if I were to rewrite this, x minus something, what am I subtracting to get positive 4? A negative 4. So it's really opposite what it looks like here. It looks like a positive 4, a is negative 4. In this one, it looks like a negative 3, it's 3. Because it's, what are you subtracting? A positive 3. That's how you pick out the a value. All right, let's see it in action. So the first thing we need to do is we need to find the a value. We see it's 3 up there. So I'm going to put a 3 right here. The next thing is the coefficients. Now notice these are in descending order and there's no missing terms. So we are going to just use the coefficients. 2, negative 11, positive 18, and negative 15. Now what that's going to do for us is get us our final answer when we do a special method of getting there. Here it is. The first thing I have to do is I have to drop this right inside the box. The very first term just gets dropped right down there. The next step is a step that's going to be repeated over and over, and that is I take this outside term, multiply it times the inside, and put it here, which 3 times 2 is 6, right below the next number. The next step in the process is to add straight down, and I fill in the next spot inside the box, and in this case, a negative 11 and 6 is negative 5. I repeat the process. Now I'm going to get these out of the way just to make it a little easier for us to see what's going on. 3 times negative 5 is negative 15. I'm going to again add straight down. 18 and negative 15 is 3. Let me move this out of the way if I can. There we go. Delete. Well, it's being stubborn, so I'll just do it that way. The next one, 3 times 3 is 9. And when I add straight down, negative 15 and 9, negative 6. That in red inside the box is going to give me my answer when I divide the original polynomial by x minus 3. The first thing is going to give me my remainder. This is my constant. My x term and my x squared term. So here we go. 2x squared minus 5x plus 3. And you can either have a remainder of negative 6, which sometimes they want a quotient function, quotient expression, and a remainder expression. I like to say plus the fraction, negative 6, over what we're dividing by x minus 3. If you're asked to find the remainder would be negative 6. If we were actually to multiply this entire expression by x minus 3, we would get that back. Let's try our next example. All right, so A, what do you think? -2. My values up top here, 4, 3, 2, 1, no variable. I'm not missing any. So 1, 2, -3, 2, 16. Now be careful not to put these singles too close to each other. It might look like 12 if you had the 1 and 2 too close. Okay. Bring the 1 down. -2 times 1, -2. I add straight down, I get 0. Well, anything times 0 is 0. I add straight down -3. -2 times -3 is +6. I add straight down, I get 8. -2 times 8 is -16. I add straight down, 0. What's amazing about this is how fast it is compared to long division. But there is that restriction that this has to have a 1 coefficient, and that certainly restricts the use of this. This is my remainder, my constant, my x squared, and in this case, my x cubed value. Now, you don't have to go in that order. You can go the reverse order. And what I mean by that is my biggest exponent for the variable is 4. This is always going to be 1 less because we're dividing by y to the first. So 3, 2, 1, constant remainder. Now, if the remainder is 0, then y plus 2 is a factor of this polynomial, and it went in evenly without a remainder. So x to the third minus 3x plus 8 is my answer to this problem. Let's take a look at number 7. Now this is what we refer to as synthetic substitution. We're going to do the same process, but what's going to happen is if we were to plug in -2 in place of x here, function notation, and plug, that means I'm going to plug -2 wherever x is, and simplify that expression, that's going to be equivalent to what I get from my remainder. That's synthetic substitution. So this is a way of doing the substitution in a polynomial function like this without actually doing the substitution. So I'm going to put my, now please note that -2 for x, I'm going to put -2 here. I'm not changing the sign here. This is not x minus 2. This is x is -2. So we're plugging it directly in. I have my values 1, -4, -4, -5. Let's do some work. Drop it down 1 times -2, -2, add -6. Be careful of not multiplying. Now multiply -2 times -6, +12. I add -4 and 12 is 8. Multiply -16. Add, get -21. Now, I have to put my money where my mouth is. I said that P of -2 is going to have to be -21 right there. That's what it's supposed to be, right? I'm saying that's negative. Helps if I use something else. I'm saying that's -21. Now, I have to prove it. So, I think I have enough room. But I can't see my original problem. Here we go. P of -2. So I have to take -2 and cube it. -4 times -2 squared, -4 times -2, -5. This has to equal -21, or I'm going to look silly. Let's see. Negative 2 cubed. Negative 2 times negative 2 times negative 2 is negative 8. Negative 2 squared. Negative 2 times negative 2 is positive 4 times negative 4 is negative 16. Negative 2 times negative 4 is positive 8 minus 5. Well, these two are going to cancel each other out. Negative 16 and negative 5, negative 21. That is synthetic substitution. Now let's do positive 5 for this same problem. Now I'm just going to copy this and put it down the bottom because it's going to be the same for both. I'm going to have to move this further down so I have room. All right. Put that right over there. I think I need a little line between them. All right. And we said we were putting positive 5 in here. Let's see how it works out. 1 times 5 is 5. Add 1 times 5 is 5. Add 1 times 5 is 5. Add 0. So P of 5 is 0. If 0 is the result when you substitute it in, it turns out, and we're going to learn that work with this more next time, it turns out that x minus 5 is a factor of, I can't make a t anymore, it's a factor of that original polynomial. But we'll play with that more another day. All right. Let's take a look at this one. They want to know, I believe the instructions for this one are something about, is this a factor? There it is. Use synthetic division to find the polynomial quotient and remainder. Is the divisor a factor of the dividend? In other words, does it go into it evenly? If x minus 3 goes into it evenly, then x minus 3 is a factor. All right, so here we go. Watch out. 5, 3, no variable. Where's x to the 4, x to the 2, x to the 1? They're all missing. So when I write this out, and I've got my x to the 5th, I have one of those. I have 0 x to the 4. I have negative 1 x to the 3, 0 x to the 2, 0 x to the 1, and negative 210 x, no variable, or x to the 0. Remember, opposite sign of what it looks like here, right? Because it's in the parenthesis, opposite sign, so I need positive 3. And let's begin. 1. 3 times 1 is 3, add 3. 3 times 3 is 9, add 8. 3 times 8 is 24, add 24. 3 times 24, let's see, 60, 72. Add 72. 3 times 72, 216, I believe. 210 plus 6, yes. And then I add straight down and I get 6 here. So, now some books say Q of x, as in the quotient, is going to be the, let's see, this is x to the 4th, so x to the 4th plus 3x to the 3rd plus 8x to the 2nd plus 24x plus 72. And then they say R of x is 6. Now, personally, this is, by the way, this is not a factor of the original polynomial up top here. It's not a factor of that. But I prefer to write it x squared plus 3x, sorry, not x squared, x to the fourth plus 3x to the third. Is that right? Fifth, yes. Plus 8x to the second plus 24x plus 72 plus 6 over x minus 3 as the entire quotient. But the reason they don't do this part when they're talking about that is because this is a polynomial function and this is a polynomial function. And that's why they do q of x and r of x. So in case you come across that, that's the reason for that. This, if you multiplied by x minus 3, would give you back what you started with. So I like that better, but q of x and r of x. And that's all there is to it, folks. I hope that helped. Have a great day.